Okay, so we should be on the last page here, page 3. And we want to make sure we're utilizing Desmos appropriately and efficiently, because it's not bad when we're only plugging in an input of 1 or an x value of 6, a whole number. But we know that a lot of times things like gigabytes of data might be measured in quite a few decimals. So we want to see how using Desmos can help us to kind of make things go quicker. So we're going to use this same function, the b of x equals 10x plus 25. So we're going to go to Desmos, type it exactly as it appears, and then we're going to use this exact notation, which we've done before when it comes to Desmos. But we're going to type these in, and we're going to look for those answers in those gray boxes there below. Okay, so we're going to go here to Desmos. We're going to type in our b exactly how it appears. Capital B and a lowercase x. Because look, here's a problem. That's no good. We don't want to see that. So lowercase x equals 10x plus 25. And then below, we're going to put capital B parentheses 6. Exactly how it shows up on our page there. And we see that gray box. We're like, oh, cool. Our bill will be $85. Okay, great. So we go to here, that b of 6, let's not write in a highlighter, that b of 6 is equal to 85. Again, plugging in 6, not that bad. But we get to something like 2.75, and, you know, it's not as fun to fill in 2.75 and figure that out yourself. But look at how quick that was. As long as we define the function b of x at the top, then we can use that function letter b, and then we can type in any input we want, and it's very, very quick. So that looks like $52.50. So b of 2.75 is $52.50. I guess I'll put dollars since we're talking about that. And then you would imagine that sometimes your data can be measured to even smaller decimals. So 1.482. So now we go again, capital B. Look how short this is. We're not plugging in any numbers for x. We're not replacing them and then multiplying and then adding. No, you type in capital B, which tells the computer you're talking about the same function up top, 1.482. There's your $39.82 bill. All right, so 32, what was it? $39.82 bill. 39.82. So B of 1, 39.82. Can't forget it. 39.82. Look at that. Okay, so now it comes. Look at what we're being asked in number 2. So in number 1, we're being given an input because inside the parentheses is getting replaced. And that's an input, means we're replacing x. But in number 2, it's now saying b of what x value would give us 93. So how many gigabytes, really what we're saying, would you use so that your bill would be $93? So now we're searching for the x value. Well, here's a great thing that we can do. Is then we put this into Desmos and watch what happens. We put this into Desmos. So we do b, same thing. We can even use b again. That's the great thing, equals 93. And now there's another function that pops up on our graph. And all we're looking for, let me take these out so they're not confused here. All we're looking for is when will this purple line be equal to 93, is we're really looking for an intersection point. And look at that. You'll have to use 6.8 gigabytes in order for it to cost $93. So we use that here, is that x equals 6.8. So we get x equals 6.8 because that's where we found an intersection. Okay, so same thing. We can now change this to 42.1. So let's change this to 42.1 instead of 93, 42.1. So now again, we're looking down here. Look at that. We got an intersection at 1.71 gigabytes. So certainly we did expect that we were going to use less. So x equals 1.71. And then if we have a really expensive bill of over $116.25 to be exact, we could back this out. And look how quick this is. There's no equation solving, but we're thinking about, we're like, okay, fine, yeah, where's the function going to be the same as 116.25? So we got 9.125. 9.125. So x equals 9.125, which means this is 9.125 gigabytes for a 116.25 cell phone bill. So using Desmos and then searching for those intersections is a great strategy that we can use. Okay, so lastly, let's think of the cool down here. The college student also found a third plan that has the 2 gigabyte allowance. Function C is 30x plus 5. 30x plus 5. X is still the gigabytes. So we're going to find C with the input 0.7 and explain what that means. Okay, so if C of x is equal to 30x plus 5, then C of 0.7 just means we're going to put 0.7 in for x. Let's see. So 7 times 3 will be 21, but we add the 0 for the 30, but we take away a 0 because of the 0.7. So I'm thinking this still just comes out to 21. So this is just going to be 21 plus 5, which is going to be a $26 bill if you use only 0.7 gigabytes. So a $26 bill for 0.7 of that gigabyte overage. Because that's what we're saying, is the input is 0.7, the output is 26. The input is the amount of gigabytes, the output is the cost, seeing as the monthly cost is given by C. Okay, so number 2, her budget is still $50 a month. So what can she, essentially, how many gigabytes can she use? So we could certainly use Desmos if we wanted. We could plug these in, but it's always nice to math when we can math. So let's see, if we now know that we want, as we come up here, now we want her bill to be 50. So when does 50 equal that prescription of what the bill is? Let's see, let's subtract 5 on both sides. So we're going to get 45 equals 30x. We're going to divide by 30. What's 45 divided by 30? Well, let's see. 30 goes into 45 1.5 times. So x is going to be 1.5, which means you could go 1.5 gigabytes over to keep a $50 cell phone bill. So, aren't you guys glad you have an unlimited plan? All right, there he is, page 3.